North Dakota, we have Matt Sagaser, who is the Director of Innovation Accelerated, and Joel Honeyman, the VP of Global Innovation. Welcome them to the stage, please.
Thank you. All right. Well, good afternoon, everyone. It's a pleasure to be here. As our esteemed speaker just introduced, my name is Joel Honeyman. I'm the Global Head of Innovation at Bobcat.
All right, good afternoon, everyone, and my name is Matt Sagaser, and I'm the Director of Innovation Accelerated at Doosan Bobcat.
And I think what we want to talk about today is, our usage and our thoughts around using augmented and virtual reality. But I think one of the things that we want to talk about, and we heard about it in some of the speakers here this morning, is that there's enabling technologies first. That augmented reality maybe onto itself isn't a solution, but combined with other different technologies does and can create a whole new solution. So I think you might enjoy this little bit of this journey when we think about how we can implement this technology in our business and construction equipment. So first thing, who is Bobcat? Just a shameless plug about who we are. Well, we're based up in lovely West Fargo, North Dakota. That's our roots. That's where we started more than 65 years ago, and maybe you've heard of us or seen us. We're the white loaders and other implements that are on construction sites all across the globe. We're pretty proud of the fact that we've made about 1.6 million of these. We make them more every day as we go forward, and so this is probably the base product people think about. We have some others.
So our product portfolio has really expanded over the years, and as you see in the pictures here, we have very small equipment that are utilized on landscape job sites and grounds maintenance job sites, so zero-turn mowers and things like that. Small mini loaders that are also used in landscaping, all the way up to some of our compact equipment like excavators for trenching, and then our skid steer loaders and our compact track loaders, and a lot of products in between there. And maybe even more importantly is the attachments. We've got thousands of different implements that are utilized on the front of the machine. We call that our tool that really make the machine what it is.
Okay, so when we think about a job site, and we think about a construction job site, obviously probably all of you have seen a construction job site. There's multiple pieces of construction equipment that's on that site. But the key thing is this is commercial equipment, right? We're not in the consumer space. Commercial people, they've got a job to get done. They've got a building to get done, a foundation to get made. They've got concrete to pour. And so they're working on all these different aspects, and they really hone in on what? Accuracy, speed, being efficient. And so remember those words, because that's really important when we start talking about the construction industry and the interactions of our operators and these machines working together.
All right, so let's talk a little bit about the job site of the future. We love to use that vernacular because it's important as technology continues to advance. So what might this look like for construction, for grounds maintenance, and products like this? We believe that there's many tasks on a job site that really require precision work. So when you think about slope and grade as you're moving material with a front end loader, or moving material in a trench with an excavator, or mowing grass, elevation is really important in being able to understand actively what's happening with the machine you're operating, and using that machine also to move objects and to avoid objects. We'll talk a little bit about those applications as they are important as the operator or the customer is integrating with the machine and the job site and connecting its devices with its equipment.
So what was the opportunity statement when we started to think about this? And again, Matt and I, we have a whole team we're called the innovation team at Bobcat. And so we work on these different things. And so our statement was, how might we supplement the operator with additional information inside a cab that has a limited amount of viewing space? And that's really important, right? These are small, compact machines. Yeah. They got to get the work done on the site. They don't have a lot of room for a lot of other things, but we want to help out our operator right? We want to remember precision, accuracy, all these other things. So how do we do that? And so what was our aha moment? Our aha moment was hey, let's use the glass in our machine as a display. And this really became the cornerstone of us thinking about, you know what, if we could unlock the secret of some technology to using the glass, we might be able to do a lot of other things for our operators.
You think about the cab, the place the operator or the customer sit on a machine really hasn't changed much in 50 years, right? It's pretty similar to where it was back in the early days. So there's glass all the way around the machine. Close to 80% of the surface area inside the machine is glass. And so there's a limited amount of area for displaying operator information today. We have a little display up in one of the corners or in the lower corner of the cab, but there's glass that surrounds the operator or the customer.
So again, loader, this is the picture of a loader, one of our modern loaders here, and you can see the red dot in there. That's focused right on that front door, the front glass of the machine. So again, this became the thesis, not just of the loader, but also of our other products that have cabs, to think about how can we use that glass.
So digging a little deeper, you take the blowout of that cab, you've got the front door or the front window, the largest surface area of glass on the machine, and you have the side windows. All these are, in our opinion, are opportunities for us to use that glass as some sort of display. So there's a lot of glass in the cab, and then Joel will talk a little more about our other products, but again, the feature here is the glass inside the cab.
And same thing, this is on an excavator cab. And so again, our thesis became, hey, we have all this glass. Why not utilize that glass as a display, regardless of the vehicle and what it might be doing?
All right, so what's our solution? Let's kind of get down to the details here. We started by looking at emerging and future technologies. And we came to this show 5-6 years ago and looked at different solutions that were available. We started out by putting a projector inside the cab above the operator, and that projector shined its laser through the glass on the front door, and it projected outside the machine. And it seemed like a really good demo. We did a POC, mocked it up, and it was great until we started driving that machine, and it didn't really work. So, and we tried with glasses, we did wearables, and we love wearables. You know, Joel and I are technology guys, and we love the application of wearables. But in the cab of the machine, we were limited because an operator needs to be able to see peripherally and around himself in the cab of the machine.
And they're contractors. They're going to lose, break, sit on, whatever you want to say, those types of wearables. And we tried them, and unfortunately, not yet. I think someday we'll probably get there. I know there's a lot of companies out here pitching wearables, but in our application, it's just not quite there yet.
So then we pivoted slightly and we decided to put holograms in the glass of the machine. There's a lot of companies that were messing with that, and it made it easier, more realistic because it was up in front of you, but the same issue with vibration as that machine was operating didn't really fit. So the next idea we had is, what about a TV? There's technology in TVs that's advancing. What about the inner workings of a TV screen? So the OLED inside the TV, it's transparent, you can see through it. It's touchable. You can move things around as you touch it with your finger inside the cab. And we can add tint, make it tintable, because with a laser or with an LED projector, sun washes that image out almost instantly when you go outside. Works great inside, great demo. Once you drive outside, it didn't work. And OLED, it's a different opportunity for us.
So this really got us thinking about this next step, because if we could figure this out, then we could probably make even a better solution for our customers. So what did we do? Well, we mocked it up really quickly. So we jumped in our truck and we went to our local Best Buy in Bismarck, North Dakota, and what did we do? We bought a 55-inch OLED TV, and we peeled that sucker apart. And we got down to the OLED filament inside to start looking at this different technology.
And it's literally a piece of plastic, very thin, pliable plastic inside the TV. Picture on the left-hand side of the screen here is that OLED out of that TV, laid it on the table and said, okay, now let's figure out a way to connect to it. And the beauty about this particular solution is that once you connect to it, it becomes like a computer screen. As you plug into it, you can project whatever you want on that screen. So that opened up some doors for us that we didn't have before. So the right-hand side shows it as it's plugged in, and okay, there's some real potential here.
We took it a step further. We brought it up in the air, and then we started to put content into it. Just static content, just being able to connect to the TV. We didn't have any connections with any of the manufacturers at this point, so we're just all doing this on our own. You can see our technician in there is, starting to play with it. And then we realized, well, this really will work. Like, we stood it up. And so what did we do next? Well, of course, we had to make a frame for it. So we did a very technical thing. There's one of our engineers. He grabbed some 2x4s and some framing material, and we framed out that 55-inch OLED in a custom frame that would fit into one of our machines. And that was really important for us because New technology has to be believable. We believe that so firmly. It's one of the taglines within our team. If I described this to people in our boardroom and I told them what we wanted to do, they would have laughed us out of there and said, go away. But since we were able to mock this up and be able to bring this to life, it allowed us to keep going, to keep looking at this different technology.
All right, so we took that frame, made out of 2x4s like Joel described, painted it black, and put it on the front of a machine. It looked great in the lab, right? Nice shiny screen, you can do a lot of different things with it, but let's take it outside and see if it's believable. So we mounted it to the front of an excavator, literally almost the same size, 55 inches tall in portrait mode, and decided to check it out outside and see if it worked.
So the next thing we did is we took and we started to add some simulations into that. So now we figured out, okay, we can do something with this, and you can see these other pictures in here. Now we started to think about what else we could do. What could we simulate? What are some of the things of the pieces of information now that we could bring into the operator if they had the ability to do it? Now this is still a 55-inch, so it was still the full screen. Again, we weren't working with any manufacturer at this point, so we were just mocking up some different things. The main thing, though, is we did this in 10 days. So in 10 days from the time that we thought about this idea to the time we built it, we were able to build this first prototype and, again, make things believable to show our organization and a few others, start talking to a few customers, that this was a possibility. But this is where it started to unlock the doors, and this is where we're going to start talking about some of the super cool features that we can be able to do once we had this pulled together.
So we're learning as we're doing this. So as we've discovered in the past, the laser projector, the LED projector, holograms and things didn't really function well. So as we're building this new prototype, we're starting to figure out that as we learn more about literally a TV screen inside the cab of a machine, that you can see through it, all right? Now we have some other things we have to solve in terms of light. So what if we added tint? Talked a little bit about that. Auto tinting. So as you go outside with this machine and it senses sun, lumens hitting the outside of the screen, it'll tint to, again, preserve the image on the screen, but then also let the operator still see out of it. We started to think about how it might apply to other machines outside the excavator platform.
So we pivoted a bit, right? Remember we had that 55-inch, we laid that in the window and that would fill up the whole screen, and we're like, no, we shouldn't do that. Let's go to a 30-inch and let's turn that, let's put that in landscape view. Now at this point, the picture we don't have in here is we actually showed this at the CES show going back, what was that, 2 years ago? We showed this at CES. We weren't working with anyone, but the president of LG North America walked by and he was so impressed, and I said, hey, let's exchange business cards, we need a little help. So now LG has been helping us with working on this specific technology because they recognize as well that there's potential in here for being able to use their OLED technology in a different format. But going to the 30-inch really allowed us now to tailor that window, or that view, I should say, within one of our products.
All right, so here's a picture of our current display. This is actually a 5-inch display that's in the corner of the machine, or in an excavator, it's in the lower right-hand part of the machine. For an operator to see it, you got to take your eyes off the job site and look over. And it's very limited in terms of what it'll show you. Here you can see we've got temperature of the machine, we've got a fuel gauge, we've got battery status on the machine, and there's some smaller items that you can see on the screen here because it's enlarged, but when you're in the machine working, it's very difficult to see. So our goal was to try to figure out how to take those display elements and make them more usable.
Yeah, so the next thing we did is we took that gauges and the live camera view, and now we mocked that up in a loader door that you can see in here. So now we started to think about other possibilities. Quite frankly, the gauges are kind of boring. Like, okay, so you can see your temperature on a gauge. That's really not what we're here about. We want to be able to give that view of the operator. Again, they're looking down. Again, typically you're looking down close to your work, so you have all this workspace up in front. This is where the 30-inch display really brought some more solutions forward to us because we have a lot more room compared to our smaller displays up in the corner. So now we started to experiment a little bit.
So now that we have that, we have the ability to bring those current display elements from that small screen onto the front screen in the front window in front of the operator. We have this transparent OLED, and we're able to manipulate those widgets on the screen. Started to think about what else. Like Joel said, there's more to this than just the current display elements that are there. How can we make this more magical for a customer and really make it more efficient and usable?
So knowing that we potentially have this quote unquote canvas that we can now use, and thinking about the job site of the future and operator of the future as we opened in here, it allowed us to think about what else could we add. So the first thing that we took a look at is a stereolithic camera. So a stereolithic camera follows the operator as they're viewing, which is really important, which we're going to come to in a minute. Tracking of eyes. You can track eyes and be able to do that within the cab as well. Now we can show grade and elevation of a job site. We have a radar sensor we've developed that's going to be commercial here in the early part of next year for guidance for objects and other things. Well, now we can display that information on there. We can upload a GIS map. So we could have a GIS map of all the utilities on a site, and we could upload that as well for that to be displayed in there, as well as all these different camera views. But this is the piece where it gets a lot more interesting. Now we can add augmented reality. So now that we had those elements that we could use, and we had the display, we can pair those two things together. So what that allows us to do is that as the operator is driving along on the site, they can see within that display, they can see the job site features. They might see something that they're supposed to do on the job, but more importantly, maybe they see some obstacles, some places to avoid. They can see underneath. We loaded the GIS map. They can look underneath and see, oh, there's a water line there. I can't dig there. I can't cross there. And so this is where we're trying to combine augmented reality, being able to help that operator on the site, bringing those elements together.
All right, so a quick video that's going to play on your screen is going to show that 30-inch screen on the window of a loader, and you can see we're able to take the camera view, either the stereolithic camera or an actual camera showing a live view behind the operator, or a 360 degree that shows above the camera, similar to what you'd see in your new pickup or your new Tahoe. And again, you can move it because the screen is touch. You can also, on the right-hand margin there, you see buttons. You can turn on and off different items. You can also turn on and off your tint ability. So if you're indoors and don't need tint, you can just leave it at a certain light texture. But it gives the operator options. So our goal here was to bring in new features to help that operator be more efficient and productive on a job site. So if you're working in an area where you need that camera view that shows me the landscape of the job site, or maybe it's just a GIS map that shows my finished grade that I'm going for, and you can kind of see progression as you're operating. And Joel will talk a little more about that.
Yeah, you can see that we can also add gyros to the machine and be able to see the elevation, the pitch and roll of the machine, which is very important for cutting grade. And so we can now display that right in front of the operator in real time.
And again, it's transparent, so you can see through it. So we're not taking away their visibility out the front. You can see through it, and you can adjust its light texture so it's brighter or not as bright, depending on where you're working.
So this is a picture of a typical job site. You can see in here, this is probably some foundation for a house or something. They had to level all this dirt first, and then they're probably going to maybe come in and pour some concrete or put some other fill material in. But this is where, again, precision. Remember in the open, our operators want to have precision in what they're doing. They want to be able to do this efficiently, save time, energy, and motion. So if you have this as the job site, and now you think about what else we might show, and in this case, this is grade, elevation, obstacles. And again, we can put the gyros on the machine. You can have all of this information on there. Those red and yellow and blue lines, those are like the utilities underneath. And now you can combine those together. And we can overlay those, and this is a simulation in here, but we can overlay those together now. And again, you can be able to see through, right? It's augmented reality. You can see through. I can see the real ground underneath, but then I can also see what those features are, drive around the site and be able to see those in the same spatial context. And that's what's really, really important. People need to be able to see that at all times.
All right, so as we kind of wrap up this story that we're telling you, we started out with an idea of taking technology to the cab of the machine. We feel firmly that vision and augmented reality technology is going to be there in the future of our equipment. Whether it's a landscaper or a heavy construction equipment operator, they're driving home in their pickups that have this technology today. Why not bring it to the job site and make them more efficient and more productive to do things that they can't currently do? So as these vehicles and these machines evolve, we know that automated functions are coming. So our goal is to be ahead of that curve, to manage through augmented reality, maybe some virtual reality, depending on what our operators are trying to accomplish or trying to do, and do it in front of people, where you're making it easier. You can use your hands and you can manipulate things if you want to. It's not required. But instead of just having a display that's not interactive, put it in front of the operator, give them the tools to do their job better.
Yeah, and I come back to what I said in the open. So it would have been easy for us to say, hey, just take AR, put some glasses on and go sit in the machine. And what we found out is that was not how our operators wanted to consume that information, nor would it allow us to solve some of the other things that we had issues with. And that was to being able to display more information. So to make augmented reality efficient, we had to solve a couple other things in advance to make a whole new display. So we created a whole new display technology. But once we did that, now we found that augmented reality can be a very powerful tool for us, combining that together for our operators. Now again, think about our operators, again, these people on the job sites. Now they can go out there, grade, elevation, obstacles, all those things that today require another person or multiple scans, whatever it might be, and making them incredibly more efficient. So right now, this is all in pilot. We have not commercialized this. We're building 10 of these prototypes right now. We're going to put these out with customers in the early part of next year and start gathering feedback, understanding the usability. Again, this is construction equipment. It's got to be durable and robust. Right. So we have that element also to work with. But we're really excited about this technology because, again, if you combine a couple of different things together, you can create a whole new solution. And like I said in the beginning part too, you got to make it believable for people. Again, I'd get laughed out of the boardroom if I would have brought this idea up the first time on a PowerPoint. But since we had mocked it up and tried it, and we made it real, now we can go out and talk to customers about it, which we have. We've had multitudes of customers try out this technology, and they're like, you're on the right path. And now it's for us to refine that. So with that, we'll say thank you, appreciate your time, and I guess we'll take a few questions if there's a question or two out there. Thank you.
We have time for a few questions if there are questions. Raise your hand, I'll bring you the mic. Oh, I'm coming.
Yeah. Oh.
Here you go, right behind you.
Sure.
Name, company, question.
Make it easy.
John Martin, thank you for your presentation. Was curious if, with your people being out in the field potentially, if you needed an offline solution or does it require connectivity?
Right now, this is not a connected solution.
Right.
This is all contained within the vehicle. So the information that they're taking in that they would have uploaded, we're all going to contain that within the vehicle. I think at some point, and we have telematics today, so we have two-way communication ability that we could download some of those things. But I think for right now, we're thinking this should be contained on the vehicle.
Yeah,
Try
so
to just keep it simple.
I'll give you an example. So we have the ability, because there's a small PC connected to this device that's all on the machine. So we can upload that GIS map and store it locally. We can also upload videos and store them locally. And we didn't present this, but you can use that screen for watching training videos, or if the operator has a question on a certain application, they can utilize that screen while they're not moving to have that interaction as well.
Yeah, but I think we felt like most of the aspects the customer wanted were live information.
Yeah.
Live camera view, live angles of the vehicle, all of those things, which are, right, those are with sensors or other things on the other pieces.
Yep.
Yep. All right.
Any other quick questions?
Okay.
Right.
All right.
All right, thank you.
Thank you. Appreciate it. Yeah, awesome.
Okay, we have one more.